Hello, my name is Collins, and I'll be showcasing the Automated Human-Centric Issues Detector, or ACID, a machine learning tool to detect human-centric issues in app reviews. The main motivation behind ACID was centered around how we develop software systems. With the rising popularity of agile development and faster development cycles, it is imperative to gather and analyze feedback on a frequent basis for subsequent development sprints. The issue arises when the amount of user feedback far exceeds the team's capacity to extract meaningful data from it. Our solution is a machine learning approach that has the capability to detect these human-centric discussions, collating the vast amounts of information in an easy-to-digest format for further analysis. The ultimate goal being a streamlined user feedback loop that will allow development teams to focus on delivering high-quality software systems to the end user, all whilst considering the user's needs. The foundation for the multi-label classification is built upon a binary relevance problem transformation method with a support vector machine classifier, both of which were chosen due to promising results from past research as well as time and resource constraints. So I'll be showing a quick demonstration of our smart tool. So here is the home page, and basically there are two types of entries the user can use, that is text entry and CSV entry, as well as the ability to train a new model. Firstly, we'll consider ourselves with the text entry. Text entry works by simply entering your sample in the text area and clicking the Generate button. What you see is the resultant label probabilities for the inputted text. And you can see here that for this text about a certain calculator app using location services, there is a 56.59% probability that it is privacy labeled. CSV entry works by uploading a CSV file that can have many samples along with a few optional parameters such as likes, dislikes, and rating for each sample. For this example, we would use COVID-safe review results.csv. If we take a look into this file, we can see our samples, which are in column 6, thumbs up, which is our likes, are in column 8, and score, which is our rating, is in column 7. So we'll just enter this file here along with the parameters 6 for samples, 8 for likes, nothing for dislikes, and 7 for rating. In the results page, we are greeted with a bar chart that tallies up the resultant probabilities of all the samples, so a sample that gained a privacy score of 0.8 contributes to this 38.57 total. Dependent on the columns entered, the user may also see charts for the likes-dislikes column and the ratings column, where the data is decomposed based on the likes, dislikes, and the rating respectively. The user may also enable a threshold, where probabilities greater than the threshold are considered to be wholly counted, where probabilities that are less than the threshold are not counted at all if the user would like a much more binary outlook. We may also download the probability labeled dataset by clicking on this link, which will download a CSV file with the samples and any extra columns we inputted with the resultant probabilities for each label. Finally, this tool offers the ability to retrain the model using a different dataset. It's as simple as entering a CSV file that fulfills these requirements, that is, in essence, a simple binary labeled CSV file. We'll be using this train.csv file, which, upon inspection, differs from our previous original model in that it does not have a gender label. Upon clicking train, ACID will train a new model based on the dataset and provide metrics on this dataset given a 3:1 training to testing dataset split. And as you can see here, there's around a 72% accuracy, 4% Hamming loss, and a low moderate micro F1 score of 0.31. Based on this new model, if we input COVID-safe review results.csv file once again, we can now see that the privacy is now at 149.32, which differs from the 38.57 total that we had with our original model, possibly indicating that coupled with the low F1 score that we saw, our new model is probably biased towards privacy. With ACID, we hope to provide a tool that allows developers to prioritize their development cycle towards certain human-centric issues located within their app or project. Thank you for watching.